Islands are nature's laboratories, isolated pockets of land surrounded by vast stretches of water. These unique environments are cut off from the mainland, creating a world where the usual rules of survival and adaptation are rewritten. Here, life is forced to innovate, and evolution takes unexpected turns. On these islands, isolation acts as a powerful force, shaping the destiny of every creature that calls them home. The separation from the mainland means that animals and plants must adapt to new and often harsh conditions, where resources are limited and the familiar threats of predators or competitors may be absent. When animals become stranded on islands, they face a host of new challenges: scarce food, fewer predators, and unfamiliar competition. The struggle to survive in these isolated habitats leads to remarkable changes in their bodies, behaviors, and even their very size. This isolation drives a fascinating evolutionary phenomenon known as the island rule, or Foster's rule. Scientists have spent decades studying this process, uncovering the secrets of how life adapts when cut off from the rest of the world. The island rule reveals that animal size often changes dramatically on islands. Species that are small on the mainland can become giants, while large animals may shrink to miniature versions of themselves. This pattern is seen across the globe, from remote Pacific islands to the Mediterranean. Small animals, freed from the constant threat of predators, can evolve into giants, a process called island gigantism. With less danger, they can afford to grow larger, outcompeting rivals for food and resources, and sometimes even filling ecological roles left vacant by missing species. On the other hand, large animals, faced with limited food and space, often shrink in size, a phenomenon known as island dwarfism. Smaller bodies require less energy, making it easier to survive when resources are scarce and competition is fierce. Imagine a small rodent arriving on a predator-free island. Over generations it grows larger to compete for food, store energy, and take advantage of new opportunities. Without predators to keep their numbers in check, these rodents can become the giants of their tiny worlds. Conversely, a herd of elephants stranded on a tiny island faces a very different fate. With limited vegetation and space, only the smallest individuals survive and reproduce. Over time, this leads to the evolution of dwarf elephants, miniature versions of their mainland relatives, perfectly adapted to their new environment. These dramatic changes in size and form are direct responses to the unique pressures of island life. Every species must find its own way to survive, leading to an incredible diversity of adaptations and life strategies. Island gigantism and dwarfism are just two examples of how evolution adapts life to fit new environments. From birds with specialized beaks to reptiles with unusual colors, islands are home to some of the world's most extraordinary creatures. The island rule is a powerful example of nature's flexibility and creativity. It shows us that life is always changing, always finding new ways to thrive, even in the most unlikely places. On islands, the usual rules don't apply. Species adapt in surprising and sometimes astonishing ways. The result is a living laboratory, where evolution's experiments play out in real time. This sets the stage for some of evolution's most fascinating stories, tales of survival, adaptation, and the endless creativity of life on Earth. Madagascar, isolated for millions of years, is a showcase of unique evolution. Among its giants was Beelzebufo, the frog from hell, a 16-inch predator that may have eaten baby dinosaurs. Its closest relatives are in South America, hinting at ancient continental connections. Madagascar's most famous giant was the elephant bird, Barrambi titan, the heaviest bird ever, standing nearly 10 feet tall. With no major predators, it dominated the landscape and spread seeds for many plants. When humans arrived, the elephant bird vanished and its extinction disrupted entire ecosystems. Madagascar's giants show how island life can create and unravel unique worlds. Some islands don't just create giants, they shrink them. In the Mediterranean, the story of evolution takes a surprising turn, where the isolation of land surrounded by endless sea leads to a world where the mighty become miniature. Long ago, the Mediterranean islands were part of the European mainland. As the last ice age ended, rising seas cut them off, trapping large animals like the straight-tusked elephant. These giants, once roaming vast forests, suddenly found themselves marooned on small, rocky islands with limited space and even scarcer food. Over generations, these elephants faced a harsh new reality. With little to eat and nowhere to roam, They gradually evolved into Paleoloxodon falconeri, an elephant that stood just 1 meter tall at the shoulder, barely reaching the height of a modern child. Dwarfism became their secret to survival. Smaller bodies meant they needed less food and water and could better endure the island's tough, dry seasons. This remarkable adaptation allowed them to persist where their larger ancestors could not. On these islands, the rules of survival changed. With no large predators to fear, being big was no longer an advantage. Instead, shrinking in size became the key to thriving in a world of limited resources and isolation. The fossilized skulls of these tiny elephants, with their large central nasal cavities, may have even inspired the ancient Greek legends of the one-eyed Cyclops, proof that nature's oddities can echo through human imagination. Island dwarfism is a dramatic example of how evolution prunes and shapes life to fit new realities. It's a process seen in many species from hippos to deer, all adapting in their own ways to the challenges of island life. On islands, survival often means shrinking to thrive. The Mediterranean's miniature elephants are just one chapter in a much larger story of adaptation and resilience. The legacy of these dwarf elephants endures, a testament to nature's endless creativity and adaptability in the face of change. New Zealand, with almost no native land mammals, became a kingdom ruled by birds. Birds filled every niche, grazers, predators, and everything in between. Kumimanu fordyce, a prehistoric penguin, stood nearly 2 meters tall and weighed as much as a gorilla. The giant moa, reaching 12 feet, became the main herbivore, shaping forests and grasslands. With no ground predators, many birds lost the ability to fly. Kiwis, adzebills, and other unique species evolved to fill mammal-like roles. New Zealand's birds show how, in the absence of competition, evolution can turn feathers into rulers. It's a world where birds, not mammals, inherited the land. Where there are giant herbivores, predators follow. In New Zealand, the Haast's eagle evolved into the largest eagle ever, weighing up to 15 kilograms. Its closest relative is a tiny Australian eagle, showing how quickly island evolution can supersize a predator. Haast's eagle hunted giant moa, using powerful talons and a deadly beak. It was an apex predator, dominating the skies and land. When humans hunted the moa to extinction, the Haast's eagle vanished too. This is a stark example of how tightly predator and prey are linked on islands. Lose one and the other soon follows. Island evolution creates and destroys unique relationships. Cuba's ancient ecosystem was a world of oddities. Giant ground sloths, weighing up to 200 kilograms, roamed the island. With no large mammalian predators, a bird filled the top predator role, the Cuban giant owl, Ornimegalonyx. This flightless running owl stood over a meter tall and hunted on foot, preying on rodents and young sloths. Its powerful legs and talons made it a feathered wolf. The evolution of a terrestrial owl shows how islands invent new solutions to old problems. After humans arrived, this unique world disappeared. Only fossils remain, reminders of how isolation breeds innovation. On islands, even birds can become wolves. 70 million years ago, Hayteg Island in prehistoric Europe was a land unlike any other, a lost world where the rules of evolution were rewritten. Isolated by ancient seas, this island became a natural laboratory, giving rise to some of the most peculiar dinosaurs ever discovered. Sauropods like Magyarosaurus, which elsewhere grew to the size of buses, here shrank dramatically, reaching only the size of a horse. This dramatic reduction in size was a direct response to the island's limited resources: less food, less space, and fewer opportunities to grow large. Hadrosaurs and other herbivorous dinosaurs also adapted, becoming smaller and more agile to survive in their confined, competitive world. These plant eaters developed new strategies for finding food and avoiding predators, thriving in dense forests and open clearings alike. Predators too evolved in unexpected ways. Balaur Bondoc, a raptor unique to Hayteg, developed not just one but 2 sickle claws on each foot, a feature unseen in its relatives elsewhere. Its body was stocky and muscular, built for power rather than speed. With fused fingers and an exceptionally strong grip, Balaur became a specialized hunter, perfectly adapted to the challenges of island life. Its unusual anatomy hints at a predatory lifestyle that may have involved ambush and grappling with prey in dense vegetation. These remarkable adaptations were all responses to the unique pressures of island living: scarce resources, smaller prey, and the constant need to outcompete rivals in a restricted environment. On Hayteg, survival meant innovation. The fossils of Hayteg's dinosaurs reveal more than just changes in size. They show how isolation can reshape entire body plans, leading to creatures with features never seen on the mainland. Scientists continue to study these remains, uncovering new surprises with every discovery. Dwarfed titans like Magyarosaurus and double-clawed predators like Balauerbondoc were the products of a world apart, a place where evolution took a different path, creating animals that seem almost fantastical. Islands have always been places of evolutionary experimentation, where the unexpected becomes reality. From giant tortoises to flightless birds, and in Hayteg's case, miniature dinosaurs and bizarre predators, isolation breeds innovation. Today, the fossil record of Hayteg offers a rare window into how life adapts and transforms when cut off from the rest of the world. Each bone and footprint tells a story of survival, adaptation, and the endless creativity of evolution. Even the mighty dinosaurs were not immune to the island rule. On Hayteg, they became smaller, stranger, and more specialized, reminders that in nature, isolation can lead to the most extraordinary changes of all. Hayteg's strangest ruler was Hatzegopteryx, a giraffe-sized pterosaur. Unlike its delicate relatives, it had a short, thick neck and a massive, reinforced skull. With a wingspan up to 12 meters, it was one of the largest flying animals ever, but on the ground it became the island's apex predator, stalking dwarf dinosaurs. Its powerful beak was a weapon used to bludgeon and kill prey. Hatzegopteryx filled the role of top carnivore, a job usually reserved for giant theropods. On Hayteg, a flying reptile became king of the land. Island life can turn even a pterosaur into a super predator. The island rule isn't just ancient history. It's alive today. The Komodo dragon, the world's largest lizard, rules Indonesian islands as an apex predator. Its size is a product of isolation, with no large mammal competitors. On Flores, the tiny human species Homo floresiensis lived alongside these giant lizards, a real-life pairing of gigantism and dwarfism. The Komodo dragon is a living reminder of evolution's power on islands. From giant lizards to hobbit humans, the island rule continues to shape life. Islands remain nature's wildest laboratories where evolution's experiments never end.